Welcome back, everyone. Moving on from incentives and kind of adding to that, we will be covering in this series of videos expected value and feedback. This is a really interesting approach to motivation and behavior, which takes the approach of humans being more rational thinkers and has just more of an economic approach. So, expanding on incentives, we'll be focusing not just on what we anticipate will happen, but also the value, the subjective value of that outcome, as well as the likelihood that that outcome may occur. And so we'll go over this topic with three videos, including this first one being just more of an introduction to rational models and violations of these models. And we'll get into utility and prospect theory before finishing up with Froome's model. So again, going to, in this video, just provide a relatively brief introduction on rational expected value models in general. And so with these expected value models, the basis of these models and approaches is that, again, people are inherently rational. And so with that rationality, people pay close attention to long-term payoffs. And so expected value, what it is, can come down to something like a math equation. And so expected value equals the probability of a given outcome by the value of that outcome, subjective value of that outcome. And so a lot of gambling scenarios would fit into this. And the overarching theme here is that motivation equals the expected value of a behavior. So when you're going about deciding whether or not to act or behave in a certain way, the idea is that you may be thinking, if I behave in this way, what is the probability of the outcome, and will I like this outcome? So in other words, if I put in X amount of hours of work into a given class, what is the probability that I'll receive the grade that I want, and how important is it to me? How much would I like receiving this certain grade? Another example is, again, getting at those gambling types of scenarios, press your luck. So this is a television show where you can try and get one of these options here on the board. And so obviously you're going for one of these higher numbers, right? You want to win $3,000, but there's also the possibility that you will lose all your money. So when you're looking at that board, you have to decide, okay, what is the actual probability that I'm going to get this outcome that I want to have, like the $3,000 or something of that nature. Obviously, it doesn't always have to be related to money, but those are kind of the easiest examples to conceptualize these models with. So expected value theory, this has a long-standing basis in economics, again, going from that more rational perspective and the idea of long-term payoff. So we're thinking about if we should buy things or invest, and getting at what these expected value theories are getting at is we should only buy things, invest in things, spend our time on things when the long-term payoff is better than whatever that cost is. A separate question is, obviously, can we accurately determine this? So another example of this would be a lottery example. And so let's say 2 million $1 tickets are sold for a price of $1 million. The expected value, right, would be 1 in 2 million. Let's say that those are the chances of winning this based on 2 million tickets being sold. The actual lottery odds are even worse than this, right? But and then we'll multiply this by the 1 million tickets, or sorry, the prize of $1 million. What we end up here is the value of tickets being about half a dollar, so 50 cents. And so in this scenario, based on the expected value model of motivation, behavior, and rationality, this wouldn't be worth it, right? Because each ticket is technically worth about half a dollar, but we're paying $1 for each ticket. Obviously, people still do this pretty frequently anyways. And so this is a case, one of quite a few cases we can think about where the rational perspective is not always followed. And so, in other words, the psychological value that we come up with in our heads isn't strictly rational from this numeric standpoint, and these are not equivalent. Finally here, going to go over another violation of expected value. Again, you probably think of quite a few examples of this as humans. Although maybe we think we are, sometimes we are not always consistently rational thinkers. And so the St. Petersburg paradox I find it interesting, and it's another example of this. And it surprised me the first time I was going through it. Basically, let's say you have the option to play this game and you can flip a coin until tails appears. And each time, or not until tails appears, you want tails to appear. And each time that tails appears, you will double your money. And so for an example, on the first flip, you get tails, that'll be $2. On the second flip, $4, third flip, $8, fourth, 16, so on and so forth. And so the question is, how much would you be willing to spend on this game? In other words, what is the expected value? What do you think the odds are of getting to a third flip, fourth flip, fifth flip, things like that? And actually, it's kind of surprisingly, it seems as though the average amount of money that people are willing to give to play this game is about $8 to $10 or something along those lines. But based on the expected value, and this is what surprised me the first time I was going through this game is based on expected value, and the way this works, it's worth an infinite amount of money. And so how that works is this little math equation here, basically in a word format. So we're going to start off with 50% chance of heads or tails, right? So 50% chance to get that tails. And if you get it, you get the $2. This is going to end up being $1, right? Same thing for this here. You're gonna have a 25% chance to then again get tails for the second time. And if you do that, then you'll get $4. This again is going to end up with a total of $1. And the final equation here is just 1 divided by n multiplied by n, which is always going to end up equaling 1. And so that leads to this equation here, which in other words is just infinite value, because based on the rationality behind this, which at first glance, at least for me, didn't make a whole lot of sense, but the math works out to just being about $1 each time. And so in other words, an infinite amount of money to keep going and going and going. Obviously, the odds of determining whether or not you're going to get a tail 8 times in a row, 10 times in a row, 3 times in a row, 1,000,000 times in a row plays a large role in how we conceptualize this. But yeah, based on expected value and this equation here, you should be willing to give all of your money in the world to play this game. So just an interesting example, second example of a violation of expected value and how we ourselves conceptualize the probability of a certain outcome and how much that outcome is worth to us in terms of determining how we behave. So yeah, that's it for this first video, just an introduction there. We'll get into prospect theory and temporal discounting in the next video.